Assalamualaikum and a very good afternoon. We are from Group 2.3 presenting our project that is STAIR RAMP. This is our group member. The table of contents for our project is starting with background of study, design description, engineering analysis, computer simulation, impacts, cost, discussion, and lastly conclusion. This is the background of our study. For this semester session, the Malaysia Prihatin team had been chosen as a guide for us to make a product that has a connection with this team. We had been given a task to make a product that can help Malaysians in every aspect of their life. As for this team, we had been chosen to build a product STAIR RAMP for our project. This product has a lot of function and it will help the handicapped person to move easily. Now, we move to the problem statement. There are too many constructions of stairs that are not include the slope for the wheelchair user. The consequence for this problem is they had to carry the wheelchair by themselves. Slope provided for the wheelchair are too steep and it can be dangerous. Others had carried the portable stair ramp with them, but the ramp is too heavy and difficult to carry around. The objective of our project are to analyze the problem for the wheelchair user, to design a portable stair ramp that can be used easily, and lastly to analyze the functionality and the compatibility of the stair ramp. This is the scope of our ramp that is easy to be used, can be easily stored, and need to be lightweight that can be carried around. The design of our ramp is guided by the customer requirement and engineering characteristics. The customer requirements are rigidness, easy to carry, affordable, stable footing, simple installation, not too slope, easy to handle, and rough surface. And for engineering characteristics, it must be toughness, stability, durable material, time to install, weight, coefficient of friction, gradient of the ramp, and weather resistance. The design description. This is the full assembly of our ramp that contains hinge, connector, led lock, hook, handle, and platform. This part shows that the main assembly of our stair ramp, which have a top view, iso view, side view, and bottom view. Next is the exploded view. For the material selection, it has to be stainless steel, mild steel or low carbon steel, and aluminium. And for the criteria, constraint. They are high density, high hardness, resist corrosion, and yield strength. And the second criteria is the objective. They are lightweight material and to make sure the stair ramp portable. Lastly, we go to the material analysis, which is talk about the detail of our material. This is our another material selection, and it has to be stainless steel, mild steel, or low carbon steel, and brass. And the criteria are constrained. They are low density, high hardness, high tensile strength, and yield strength. And the second criteria are objective. They are minimize the cost of the material and as a main component to support the platform. The detail about our material is shown in the material analysis below. Working procedure. Firstly, carry out from storage. For example, our ramp can put into the bonnet of the car. Secondly, combining two platforms into ramp. This is because our ramp can separate two parts and can be combined to be one part. Thirdly, opening the ramp. And the next, placing the ramp on the stable place, and lastly, wheelchair being pushed on ramp across our ramp. For information, all these working procedures shown in the animation video. How the weight of our stair ramp is determined. Firstly, we find the volume of aluminium plate. And secondly, find the volume of rectangular hollow aluminium. And volume of mild steel angle bar. To find the total mass of the STAIR ramp, we need to know the density of mild steel, and the density is 7,870 kg per meter cube, and the density of aluminium is 2,710 kg per meter cube. And next, we can find the overall weight for STAIR ramp, and when carry it around, it will be split into two, so 15.2 kg divided by 2, it can be 7.6 kg each. Now we move to the manufacturing process. In this fabrication process, all the parts and the material below are used for portable STAIR ramp, and the parts are L section, aluminum plate, hollow beam, hook leg lock, approaching plate, connector, hinge, platform, bolt screw, screw hinge, and holder. Platform, hollow beam, and approaching plate are manufactured using aluminum that purchased at shop. A section, which is made from mild steel, was cutting using Bosch GCO professional cut-off saw into a piece with 71 cm long each. Hollow beam, which is at a support, was cut using Bosch GCO professional cut-off saw into 12 pieces with 35 cm long each. Then the edge was smoothened using Bosch grinder. For the L section and hollow beam were welded using tack welding because it can connecting each other. This process were repeated to the other part which four part together. And then handle is attached to the side platform using aluminium, and the hinge is made from stainless steel. The platform was drilled with six holes to assemble the hinge using screw hinge. There are 4 hinges that we use in our ramp. For the engineering analysis, the purpose of doing engineering analysis is to determine the acceptable value of equivalent stress, total deformation, safety factor, bending moment, and shear stress. For this engineering analysis, we use two methods, which is mathematical calculation and computer simulation. For mathematical calculation, we calculate the bending moment and shear stress. We use the formula F equal to ma to determine the force applied to the STAIR ramp. Then, we calculate the reaction force at B and we determine the moment at A. Then, we can determine the shear force. For the computer simulation, we had determined the equivalent stress in megapascal, total deformation in millimeter, and factor of safety of our STAIR ramp. We use the ANSYS to analyze the total deformation, safety factor, and equivalent stress. And by using the ANSYS, we also can change or do modification for our STAIR ramp based on the result obtained. And based on the figure, we had observed that maximum deformation occurs on the center of the STAIR ramp, which is the red spot, and the value is 5.9663 mm, while the minimum deformation is 0 mm. The area at which the maximum deformation occurs may contribute to the failure of the STAIR ramp. However, a deformation can be caused by external loads, body force, change in temperature, and many more. In this case, the STAIR ramp may have deformation caused by the external loads and body force. For the equivalent stress, the critical stress occurs on the bottom of the ramp, which is the yellowish color spot, and the value is 267.26 megapascal. Majority of the part only experience the minimum stress, which is megapascal. The maximum value for the equivalent stress is based on the tensile ultimate strength of the materials used, which are around 90 megapascal until 690 megapascal for aluminium. To obtain the optimum use of STAIR ramp, the maximum equivalent stress value should be equal or less than the tensile ultimate strength of the materials. Safety of factor. For manual calculation, we can use the formula Fs equal to ultimate stress divided by allowable stress. This equation has indicated that the safety factor below 1 is considered as no safety while using. This STAIR ramp is considered safe to use as the minimum safety factor is 1.0463 and 15 for the maximum value. Our portable STAIR ramp has two types of human factor, which is cognitive and physical. And, for cognitive, starting with aesthetic are users mild still as it has a long lifespan and provide excellent strength in terms of weight ratio and cost effectiveness. Secondly is place. It is a portable STAIR ramp, so it can be taken to anywhere. And thirdly is ability, can accommodate the loads up to maximum 300 kg. And lastly, easy and simple. Do not need any procedure to set up. Just open the ramp and attach to the stair. For the physical are safety or protection. There is a check plate on the platform to prevent the user from slipping down as the surface is rough. Secondly is landing. The approaching plate at the beginning and the end of the platform to make the landing process easier. And thirdly is hand position or handle. There are two holders to be used to carry the portable STAIR ramp and make it easy to bring it to any places. The size of the handle is based on the data anthropometric data from University of Yunlin, China. And this is the data of hand anthropometric from University of Yunlin, China. The handle length determined by the hand breadth. From study, the result of hand breadth was consistent with the findings, which majority of workers were below 100 mm. This study therefore considered that the handle length at least should be 100 mm. The related studies are used to design the handle in this STAIR ramp. Allowable inclination of STAIR ramp. If access to a building is too steep, it is not deemed to be a safe access and creates difficulty for people in wheelchairs who may not have the strength to propel themselves up a slope or may have difficulty slowing down when descending a slope that is too steep. Some people find they need to stop frequently when ascending or descending ramp, and therefore suitable landings are required at specific intervals to allow for this. To overcome this, we should know the suitable inclination and maximum rise of the slope based on the situation. The table shows the guideline from the building regulations. For human and wheelchair analysis, a typical wheelchair has a length of 106.7 cm, a height of 91.4 cm, seat height around 49.5 cm, and a width of 63.5 cm. Our STAIR ramps are compatible to be used by a wheelchair with the same dimension as above or as long as the width is less than 73.6 cm. This is the completeness of our STAIR ramp. First is portability. The STAIR ramp can be detached into two and easily can be carried. Handle install helps the ramp to be carried like a briefcase. Handle design that based on anthropometric data from University of Yunlin, China. Secondly is durability. Using a heavy-duty hinge that costs 22 ringgit each. Hinge use made from stainless steel, durable and anti-corrosion. Overall material on the ramp that are mild steel and aluminium that is durable on weather in Malaysia. And thirdly is friendly size. With only 36 cm, the length 35 cm. When it is folded and detached, the size is easy to fit in small space. Simplicity. For reliability, with the material of the STAIR ramp is made of metal, the product is not easy to break and durable for a long time. And for serviceability, our product do not have any electronic part. The mechanical part is not easy to break. Just sometimes put oil on the hinge so the opening of ramp becomes smooth. And for the practicality, the STAIR ramp is easy to use. The user do not have to refer manual book when open and close the ramp. To finish the final prototype, we have been inspired by the product at the left. This is the dimension of our STAIR ramp. Let's see the performance of our STAIR ramp. There are two impacts on our ramp, which are safety and health concerns, and environmental and sustainability concerns. The functionality are 80% of the customer requirement are success. The customer requirement are rigidness, easy to carry, simple installation, not too slow, but our ramp is not affordable. This category is unfortunately cannot be fulfilled because the safety and the portability is the priority in designing the ramp. Easy to handle, rough surface, and stable footing. Next, we move to the costing. The total cost for our components are RM355.50. For the break-even point analysis, the BEP unit can be found by using the formula fixed cost divided by selling price minus variable cost, and we get 156 units. And the BEP cost can be found by selling price times BEP unit, and we get 85,800. The graph shows the break-even analysis. The break-even point is 156 units. That is 85,800. Before the BEP, the total cost is higher than the total revenue. So this region is known as a losses. After the BEP, the total revenue is higher than the cost. So this region is known as a profit. We start making profits after selling 156 units. Discussion. This is the comparison between the customer requirement and the engineering characteristics. For the customer requirement have rigidness, easy to carry, easy to handle, affordable, stable footing, not too slow, simple installation, and rough surface. And for engineering characteristics have toughness, durable material, weather resistance, weight, stability, gradient of the ramp, time to install, and coefficient of friction. This is the comparison of previous design and the latest design. The latest design of STAIR ramp had been improved by making the platform part to be identical with each of them. These four identical platforms will be easy to be fabricated since we use the same dimension. It will also cut the labor cost to make it. Furthermore, the connector on the ramp had been added into both of sides. It will help to hold more tight. Constraints and improvement. For the constraints, number of people to use the STAIR ramp is limited because the weight that STAIR ramp can afford is limited. There are 300 kg. The user should be balanced on the STAIR ramp because there is no side protection that they can tip over. The price is a little bit expensive. And for the improvements, LED lock was added to prevent the ramp from suddenly opening. Use jet plate to increase the friction on the platform. Safety and portability of the ramp increase because we use the aluminium, so the ramp become light. Lastly, we go for the conclusion. The model undergoes spin element analysis using the ANSYS workbench software to find out the stress distribution patterns. the deformations and the safety factors of the stair ramp. The goal of the project had been met as it is to build a stair ramp that encounters the specifications set by World Health Organization and fulfill the customer requirements. Although engineering characteristics also do not exceed the specifications set by World Health Organization, the product will help a lot for Malaysians, especially for the wheelchair user. The team of Malaysia Prihatin also had been satisfied because the stair ramp will help Malaysians whom are in need. Thank you.